So now we're going to be dealing with other shapes that we haven't been dealing with before. So they're going to be different than all these ones here that we've dealt with. Okay? We're going to introduce new ones now. Don't worry. You'll actually probably like these ones maybe a little bit better. So yeah, okay. So shoot, I don't know what shape it's going to be. So what do? I can go over to Desmos. Let me minimize that. Move Desmos over, and you can see. So I inputted x equals y squared. And if you look, it's a parabola that's going sideways. So instead of it going up like y equals x squared, it's x equals y squared. So it was sideways. Okay, so we kind of know what it's going to look like now. Now I've got to think of what would be some reasonable points if I wasn't going to copy this off the graph. Sorry, I'm trying to move this over. Oops, let me pause. So what would be some good points? Well, I do know that if x was 0, what does y have to be? 0, because when I square anything, it's still 0. Okay, let's try 1. Well, if x is 1, is something squared going to give you 1? Oh, okay, well that works. That's 1. All right, let's try 2. So 2, what squared is 2? Well, I know the square root of 2 squared is 2, because when you square a square root, the inverse cancels each other. But do you think I really want to do that? No. So what would be another way I could approach this problem? Maybe instead of finding the x value first, I find the y value, and then it'll give me the x value. So if that's a 0 and that's a 1, I'll try 2. So if I plug in 2 squared, what's that? 4. It's kind of backwards, isn't it? Next, I'll try 3. 3 squared is 9. Next, I'll try 4. 4 squared is 16. 0, 0, 1, 1. 4, 2. 9, 3. Well, shoot. This is only giving me this, which is a half u. But on the graph that we saw in Desmos, it's doing the bottom too. So what am I going to have to do? I'm going to have to show you y values. So if I square -1, it turns positive. 1, -1. If I square -2, it turns positive. Excuse me, sorry. 4, -2. And now I can see it a little bit better. All right, domain. Well, domain is everything to the right, everything to the left, but it's only going to the right. So it starts here at 0, 0. X is greater than or equal to 0. Set notation. Interval notation, 0, positive infinity. Excuse me. Range. Range is everything up and everything down. Well, hey, look at this. This is going up, and hey, look, this is going down. All real numbers, negative infinity, positive infinity. It's almost like they're almost like opposites of each other. Well, when it was the u, this was all real numbers, then this was the range, so it switched. Interesting. Okay. I'm so sorry. The x-intercept is something comma 0, and the y-intercept is 0 comma something. So if I plug in 0 for y, well, 0 squared is 0. The only way that that is 0 is if that is also 0, because we found that out. If this is the x-intercept, it's also the y-intercept. Okay. The vertex is also 0, 0. Is it a function? If I draw this, it is not a function. Because, let me give you an example. I don't know if you remember a long time ago, probably in IM1, they did the whole soda machine. And let's say I wanted a soda and I wanted 7-Up. Okay, so I pressed B2 and I got 7-Up. But then I pressed B2 the next time and I got Pepsi. What's going to happen if I press the exact same button, but I get something else? I'm going to be moody. That machine does not work. So if the x is the same, but the y's are different, it is not a function. But I could do B2, get 7-Up, and then I could go do the B3 button and also get 7-Up, because it could be so popular that you press more than one button. So the y's can be the same, but the x's cannot. Otherwise, it's a working machine. The shape, we'll just say like this, a sideways U. Okay. All right. Let me graph this one sec. So I graphed this one this time. There it is. And this time it's a circle. So if the x is squared and the y is squared, and there's a plus, it looks like a circle. Okay. Let's see. Now, how are we going to graph it? Well, let's look. So I don't know if anybody noticed, but it was kind of like the circle was around here. Anybody notice how that was the point, and that was a point, and that was a point, and that was a point? So I know if I plug in 5 for x, 5 squared is 25. That has to be 0. I also know that if I put in negative 5, when I square that, that also turns positive. And then that would also have to be 0. Well, what if I decide to make x 0? Then that means y would have to be positive 5, because 5 squared is 25. And I could also do the negative of that. So there's my circle. Of course, there's other points, and it would be a lot more difficult, wouldn't it? But those are some perfect ones. Anybody notice something? Well, let's do the shape. We can put a circle. Okay. We'll worry about what we notice in a little bit, actually. Domain is everything to the left and everything to the right. So it starts here at negative 5, 0, and it goes all the way here to 5, 0. So my domain is from negative 5 to 5. Or negative 5 is less than or equal to x, which is less than or equal to 5. It means it is between. Everything in here covers the circle. When it's out there, it's not in the circle. Range. Range is everything y, which means it's everything up and everything down. So I'm dealing with my y. I know I always write things from smallest to biggest. Negative 5 is less than or equal to y, which is less than or equal to 5. So it's between here. Okay, the vertex. Now the vertex is kind of like the center point, right? Well, there's an imaginary center point right there, and that's it, 0, 0. My x-intercepts are where it crosses the x-axis, 5, 0, negative 5, 0. My y-intercepts are 0, 5, and 0, negative 5. That wasn't that hard. Is it a function? Touches twice? Nope, it's not a function. So what you should notice is that today we're not dealing with functions, but in the past, every single one of these, they were a function, okay? Because it only touches once, it only touches once, it only touches once, you're good to go, okay? All right, so now I am going to do this problem. Let's see, what do you guys think? Do you think it's a sideways U or sideways parabola? Or do you think it's a circle? Well, the x is squared, and the y is also squared. I think it's a circle. So I'm going to tell you that the radius is, let me unblurry that. It's taken a second, sorry. Is 3, negative 7. I'm going to see if you can, oops, sorry. The radius is 13, and the center is 3, negative 7. So take a second, see if you can figure it out. Okay. Hopefully you notice, hey, when it's in parentheses, you do the opposite. Hey, when you do parentheses, it's the opposite. And then how the heck did I get the radius? I took the square root of that last number. And some of you go, what? Well, what's the square root of 25? 5. What was the distance from one endpoint to the center? It was a distance of 5. 5. 5. 5. So what that means is that when I graph this one, it should be a distance of 13. So let me, oh, they actually didn't do that problem. Okay? So now that we know that, let's see if you could figure out the center for this one. Negative 1, negative 4. And what would the radius be? 3. The radius, you take the square root. And then this one, you do the opposite. You do the opposite. So let's graph it, okay? What do you think I would graph first? Well, when I graph a parabola, what do I graph first? The center, the vertex, and then I graph out and out and out because it matches. So I'm going to graph the center first. But here's the truth. The center isn't actually part of the circle. The center just kind of tells you where the middle is. So I'm going to put that in pencil because that's not actually where my graph is. But I know if the radius is 3, I can go up 1, 2, 3. I can go right 1, 2, 3. I can go down 1, 2, 3. And I can go left 1, 2, 3. And now I can draw my circle. I know, I'm not very, I got other good qualities, okay? And there's my circle, which means I could also calculate the vertices. 2, negative 4. negative 1, negative 1, negative 4, negative 4, and negative 1, negative 7. Now, how could I have done that without the graph? I want you to notice, look at this. This matches distance of 3. 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 So no matter which way I go, I'm good to go. Now, is this one also going to be a circle? Yep, because the x is squared and the y is squared. It's only going to be a parabola if one of them is squared. Okay? So, what would be the center for this one? 3, 0. What's the radius? 4. Square root that. And then if you look, how come it's 0? Well, there's nothing in the parentheses. Don't forget to do the opposite. What do you think I'm going to graph first? You're right, the center. Is it a real center or an imaginary center? Imaginary. Now what do? Up 4. 1, 2, 3, 4. Right 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. Left 4. 1, 2, 3, 4. Now I draw my cute little circle. Erase that because it's not actually part of my graph. Look at this. If I add 4 to this, 7, 0. If I subtract 4, negative 1, 0. If I add 4 to this, if I subtract 4, those are my points, and it matches up. All right. Now, this time they gave you this information, and they want the equation. So here I had the equation, you gave me information. This time I'm giving you information, and I want the equation. So I know whenever it's in parentheses, I always do the opposite, squared plus. Always do the opposite. And then, let's see, if this was 9, you took the square root. So if the radius is 8, am I going to write 8 here? Nope. I'm going to square it, which is 64. Okay. Let's do the next one. Same thing. Now, some people want to write x minus 0 squared. If that makes you feel safe, great. But I know that's just x squared. Plus y minus 3 squared equals. Now, if I said square this and you get this, what if I square this? If you remember from the homework, when you have a square and a square root, they cancel each other. Some of you go, why? Well, if I have the square root of 5 times the square root of 5, that's the square root of 25, which is 5, which is what I get here. We'll work on that more, of course. Okay, I'm going to do the homework and go over that in the next video.